Hi, my name is John. As you know, some of you know who I am by now. We're going to start doing Chapter 1, Section 3 of Charles P. Mckeague. The book's located right over here. This is edition number 4. You can use it for edition number 5 or 6 or 3. Most of the books are pretty similar. So, Chapter 1, Section 3. I noticed you guys are having a lot of problems with this, so let's get started. The first thing we're going to do before we start is go over the definition of sine, cosine, tangent. Everybody should know what that is. So, katoa. Okay? So, sine of the angle is the opposite of the hypotenuse. Cosine is the adjacent side. The ratio of the adjacent to the hypotenuse tangent of the angle is equal to the opposite side, or the ratio of the opposite side to the adjacent side. Before we start doing what secant is, we're going to draw it out right over here like this. Here's your x, your abscissa, and your y, your ordinate. And we're going to draw an angle here. This is your initial side, I-N-I-T, initial side right over there. And we're going to call this the terminating side, T-E-R-M, like terminator. The terminator ends people's lives, that's where it ends. So this is in standard position, always starts at 0. So it's going to go positive to the right or up, and then it's going negative going down. So going up is positive from standard position, going down is negative. So let's draw it just to show you how it works. Positive and then negative. Now what happens is this. The CSC right over here stands for the cosecant. CSC right there. That's where the cosecant symbol comes from. Secant, S-E-C-A-N-T, first 3 letters. Cotangent, C-O-T-A-N-G-E-N-T, cotangent. There it is. We know a good way to memorize this is the sine goes with the S in the middle there. The cosine goes with the C. There's only one C, or there's 2 C's here. There's only one S here, one C here, but it goes with, of course, it's one S, but the cosine goes with the secant. So let's get started. What this looks like using secant. So if you have an angle like this, with the coordinate x, y, always radiating out from the origin. So you have to radiate this from 0, 0. This is going to be your x value, that's going to be your y value, that's going to be your radius. And we know that x and y are always perpendicular, so these are perpendicular as well. Okay? So let's get started. What's the relationship between x, y, and r? I'm going to use pink. X squared plus y squared is equal to r squared. Solving for r right there is equal to the square root of x squared plus y squared. You notice it does not equal square root of x squared plus the square root of y squared. It does not equal that because you cannot break it up when there's 2 terms right there inside. When there's a single term, you can break it up, but when there's a sum, you cannot. The sum of the radical does not become the radical of the sum does not equal the sum of its radicals. Okay. So let's get started. The sine is the opposite over the hypotenuse. So according to this angle theta right over here, so that's the angle theta. It always makes a reference with the x-axis. Got it, guys? Makes a reference with the x. That's pretty important. We're going to do referencing with the x a little bit. It's in standard position, in other words. The sine is the, according to the angle, opposite over hypotenuse. It's going to be y over r. The cosine of the angle is adjacent over hypotenuse. It's going to be x over r. The tangent of that angle is opposite over adjacent. The ratio of the opposite side to the adjacent side, y over x. Got to get these memorized, guys, because it's going to come out over and over again. The cosecant is the reciprocal function, which is r over y. Secant is r over x. And the cotangent is x over y. Okay? So there you have it. The 6 trigonometric functions. We're going to be looking at these 6 trigonometric functions like crazy. Chapter 2, 3, 4, 5, 6, 7, 8. The sine, the reciprocal again, is the cosecant with the s right over here. I'm going to put that in orange just to make sure you guys understand these are reciprocal functions. Okay, so let's get started with some of the problems. I'm not going to do the example problems for you. I'm going to actually do some of the problems itself. So let's start with one of the problems. Take a tree, split them up. Let's do problem number 1. It has a coordinate 3, 4, and you want to find all 6 trig functions. Okay. Here's a good little trick that I'm going to show you guys. Label those x, label that y. I don't know if you can see that or not. That color maybe. I'm going to label this x right here and label that y. First thing we're going to do is, I'm going to use a different pen here. We have a formula, x squared plus y squared is equal to r squared. Plugging into x and y, you get 3 squared plus 4 squared is equal to r squared. R squared is equal to 9 plus 16, 25, and the radius must be 5. Notice that the radius is always positive, okay? Radius is always positive. Okay. So how do you find the 6 trigonometric functions? We have the sine of the angle, whatever that angle is, it's y over r. Always write the equation out before you start. Where's your y? It's 4. Where's your r? It's 5. It's going to be 4 over 5. The cosine of the angle is equal to x over r, because I memorized it. X is 3, r is 5, so it's going to be 3 over 5. The tangent of the angle is going to be y over x. Always write the equation out first before you start. Y is 4, x is 3, it's going to be 4 over 3. There it is. They want all 6 trigonometric functions. We have to do the reciprocal of sine, if you guys remember that. It's the cosecant of theta, and we flip that, r over x, r over y, which is 5 over 4. I want the reciprocal for the cosine, which is the secant of the angle, is going to be r over x, because it's the flip of that, 5 over 3. And the tangent of the angle would be the cotangent of that angle, x over y, and x over y is going to be 3 over 4 or 3 over 4 here. So one of the things I want you to figure out is, write this down first, write the information x and y. The second thing you're going to do is find the radius, whatever that radius is, and then third thing is write the definitions and the formulas before you actually start solving these. You should be able to do most of these by yourself. Let's do number 19. 19 is a really good one. Or 20. You have the coordinate negative 9a, 12a. Okay? So first thing, we're going to find all 6 trigonometric functions. All 6 trig functions. Okay, I think you can see that. Okay, so first thing I'm going to do is label it x and label it y right there. And the second thing we're going to do is go x squared plus y squared is equal to r squared. X is negative 9. A squared plus y squared, 12a quantity squared is equal to r squared. Negative 9a squared is going to be 81a squared plus 12 squared a squared is going to be 144. A squared is equal to r squared. We can add those. It becomes a 5. 14 plus 8 is 225. A squared is equal to r squared. R, you take the square root of that, it becomes 15a. Oh, on this problem right here, you also notice that it's going to be the Pythagorean triple 3, 4, 5. Okay? Most of you should know that Pythagorean triple is going to come out like crazy, okay, on this Pythagorean triple. So r is equal to 15a. So I want the sixth trigonometric function. Let's start with the sine. Sine of the angle, don't copy it right there. It's equal to y over r. Y value is 12a over 15a. The a's cancel, reduce it by 3. You get 4 over 5. The cosine, let's box our answer. Cosine of the angle is going to be x over r. Where's my x value? Negative 9a over 15a. The a's cancel again. Reduce that by 3. You get negative 3 over 5. You can stop it if you want to try to see how it went. The tangent of the angle, if you remember that, was when it was tangent, y over x. Opposite over adjacent, opposite, 12a over negative 9a. The a's cancel, divided by 3, negative 4 over 3. And I'm just going to do one last one for you. What's the reciprocal function of the sine? Is the cosecant of that angle. We're just going to flip this, or which is basically instead of y over r, r over y, which is going to be 5 over 4. Okay? So first couple of 20 somewhat odd problems you should be able to do on your own. Let's do number 21 or 22. Let's see 22. One of those questions are kind of tough. That's kind of tough. Let's do number 22. It kind of looks like this. They actually gave you a graph with an angle theta, and they want you to find the sine, the cosine, and the tangent. Cosine of the angle, and then question mark, and the tangent of the angle. I hope you can see that. All of you can see that. I'm going to bring it down just a little bit. They want you to find the sine of the angle, the cosine of the angle, and the tangent of the angle. You have to try to find a point that kind of makes sense. So find a point where it's going to be pretty right on one of the corner spots. And I'm looking at it. Find your own corner. Don't find my corner. I'm going to pick a point. It's going to go 1, 2, 3, 4, 5, 6, and then probably go up 8. 6, 8. So the point that you're given is 6, 8. So we do the same process all over again. It was just added one more step to it. Here's your x, here's your y. And of course, you have to find r. X squared plus y squared is equal to r squared. Or r is equal to square root of x squared plus y squared. Radius is square root of x 6 squared, 36 plus 8 squared, which is 64. 36 plus 64 is equal to square root of 100, which is 10. I know I'm going pretty fast. This is all impromptu. I'm doing it on the fly right now, guys. I haven't worked out at any of these questions, but so I want you to use the pause button and try to decipher the information. Try to, what's the word? Digest the information before you actually start to work on some of these, okay? I know that 6, 8 is also a Pythagorean triple, is the 3, 4, 5. This 3, 4, 5 is ubiquitous. It's everywhere.